In this video, we're going to discuss finding conditional probabilities. And we need to understand what that means. And what we're going to do is define the fact that the probability of B, some event B, given that the event A has occurred. So that's what this means. It's the event B occurring given that event A has occurred. So you can read it as the probability of B given A. And that's going to be found by taking the probability of the events A and B occurring. This is going to be both of them occurring divided by the probability of A. Now remember that the probability of A cannot be equal to 0. If it is equal to 0, we have an undefined situation. And if we're going to talk about this in terms of outcomes, the probability of the event B given A is simply going to be the number of outcomes occurring to A and B and dividing by the number of outcomes occurring to A. Now the best way to do this is to actually look at an application problem. So we'll look at this table, which represents the number of men and women with various levels of education in millions. Now this isn't specified to a particular country or to a particular region, but we're just going to assume the US population. And you'll note that we have 6 categories. 1, 2, so we have not a high school graduate, a high school graduate, some degree, no college, some college, no degree, associate's degree, bachelor's degree, or an advanced degree. Remember, these numbers are in millions, so this first one would represent 14 million. Then we also have categories A and B here, men and women. Now, in order to fully be able to find the conditional probabilities, what you need to do is go ahead and sum each column and then sum each row. When I talk about summing the row, what I'm simply going to do is add these values together. And then I'm going to add another part of the table. Let's call it total. And over here, I'll call it total also. And what I can do now is add in the totals for men and for women. And so we'll just pop these into the calculator, and this will add up to 94. I'll do the same thing for women. This is equal to 101. And I want to do that for each one of my columns. So this is 27.7, 61.5, 33.1, 16.8, 36.7, and then 19.2. Now, if I've done this correct, if I go ahead and add these two values together, that should be the same as adding these 6 values together. So I should have 195 as my value right here. And I can confirm that using the calculator. So now what we're going to do is we're going to start off with a person is selected at random right here. The first question, what is the probability that the person is a man? Now, we're talking about conditional probabilities, but this first question is not conditional. It's an either or situation. We're looking at the probability that the person is either a man or a woman. In this case, we're looking at the probability of choosing a man, which is simply going to be the total of the number of men, which we already know that, it's 94, divided by the total number of people in this particular table, which in this case is going to be 195. You go ahead and divide that, and we will get a 4-place decimal of 0.4821. Now that can be converted to a percent, and we can say roughly 48.21%. But we're going to go ahead and use the 4-place decimal. Sometimes we may have to go further. It depends. We may have to go 5 or 6 decimal places depending upon what your leading digits are. So, like I said, that's a straight probability. However, number 2, what is the probability that the person is a man with a bachelor's degree? This also is a straight probability because we're just looking at a man with a bachelor's degree, which is going to be this value right here, and we're going to divide it by the total value of, or total number of people. So we can simply write this as the probability that we choose a man with a bachelor's degree. We'll call it BS for, and so that will be equal to 17.5 divided by 195. So we have 17.5 million men who have a bachelor's degree, and we're going to divide that by the total number of people of 195 million, and we'll end up with the following. And notice that I'm going to round this out to 5 decimal places. And that's because of this leading 0 here. I want to try to have the same number of significant digits. Now, let's look at part C, because that is where we're going to come up with a conditional probability. What is the probability that the person has a bachelor's degree, given that the person is a man? So now what we're going to do is we're going to be looking at finding the probability that the man has a bachelor's degree, and then we're going to divide by the probability that they are a man. So, conditional probability. Bachelor's degree given that they're a man. So, in this case, to find this, we're simply going to state, okay, we know the probability of choosing a man with a bachelor's degree already. That's going to be the probability of A and B, because we're looking at bachelor's degree and man. So that's the probability of man with a bachelor's degree. Which we already know is going to be 0.08974. But let's go ahead and write it in terms of the ratio first. And we're going to divide that by the probability of being a man. And once again, I'm going to write it as the ratio first, which in this case is 94 divided by 195. You'll note that the 195s will actually divide out of this, and we're actually looking at 17.5 divided by 94, or I can use the existing probabilities that I have, and this will be 0.08974 over 0.4820. I said 0, but it should have been 0.8421, which when I divide this out will give me a probability of 0.1862. So that's our probability that the person has a bachelor's degree, given that the person is a man. So this really becomes the probability of B given A. So this is going to be the probability of the BS given that they're a man, which is going to be equal to the probability of having a bachelor's degree and being a man divided simply by the probability of being a man.